So I will share the screen. Share. So there was some kind of mistakes with the authentication in the first workshop, but you should be able to get the problem description now. Thank you for pointing that one out, Sini. So let's do a small example. The world is not fun enough, so we need more dice games. This is my big passion in life. So we have a small program, a small game that we are going to do. So we have a requirement, the first requirement, play dice game. The player rolls the dice and the result is displayed. If the sum is 7, the player wins. Not that advanced, really. So we're going to do an analysis of this ginormous problem, and a design and an implementation. So you can see a little bit more what we are going to do in the course. Turn on the chat. So first, we do some analysis then, and that is done to understand the requirements and to find problems and flaws in the requirements. So we do this by finding central concepts in the requirements, and we link these concepts together in ways that make sense for the requirements. So in reality, everything is possibly linked to each other, but we use the requirements to not write every little possible link that is can be found, but rather the links that are needed in the requirements to understand the requirements and to make the requirements better. Can anyone spot some central concept in this small requirement? Just say something. Anyone? Yeah? Yeah, we have at least a dice. We can start there. Dice. I will use a different color. It is more fun. So one central concept is a dice. And as you said, we probably have two. At least if we have a six-sided dice. So already we are finding problems in the requirements. That detail was not there. How many sides? How many dices? Not stated. So we of course need to go back to the requirements and ask the one who wants the game, okay, do you want a 7-sided dice or a 10-sided dice or 2 6-sided dice, or what do you actually want? And we can find these problems by doing analysis. So dice, some other concept we have here. Player. Would not be much of a game without the player. Whoop. Something else? Yeah? Judge. Yeah, at least we have some kind of rules or something like that. So yeah, judge. Judge. Some form of rules. Game, yeah, we have a game, and actually I think we should make it a little bit more special, so we say dice game. So, looking at this, you can probably spot that these are pretty much nouns. Substantive from the problem description or from the requirement. So we have player, we have dice game, we have dice, And in this we have something that is a rule or judge, I think. And as also was stated, we have some problems in the requirements. They were not detailed enough. When we implement this, we could, of course, just assume that, oh, of course, we need 2 dices and they should be 6-sided because this is the most common case. But maybe that is not correct. And assuming things is the mother of all fuck-ups. So don't assume. So, but we can decide. So, we can decide that the dice game contains 2 dices. And we can understand this by saying that the player rolls the dices. And we can say that the dice game has a judge, and we probably only need 1. And possibly we could add a 5th concept, maybe the result. And maybe something like this. And the player gets a result and the judge rules the result. Oh, maybe something like this. This could be a good first step. I don't think we need to make anything more complicated for this small problem, but this is basically what we do when we do analysis. We find central concepts, often nouns, and we map them and we link them together in a way that we can add details to the requirements, we can find problems in the requirements, or we need to have information available to us when doing the requirements. Personally, I would probably not really have this part in the design model. Judges, it's not really clearly stated up here, so it's a question of making the model more complicated than it needs to be. And the result is also something that is only present for a very short time. One could argue that results are saved. Maybe you have a small notebook in the game where you write down the result and the date and maybe something like that, and you can look back and say, oh, yesterday I tried 7 times before winning. So this is supposed to be a model of reality. We can imagine this dice game as a board game. It's a box, it contains 2 dices, it contains a protocol, a pamphlet of rules. So we model reality when we do design. And exactly as Alexander says here in the chat, this is domain modeling. We try to understand the problem area. It's not very advanced problem area in this case, but anyway, as an example it will suffice. So onwards, and as you see here, no software. You don't think about software here, but reality. That is one of the hardest things to let go of when you do analysis as a software developer, because you immediately start to think about, oh, how are we going to do this? We need a database. We need all this stuff to make this work. But no, try to focus on the problem, to understand the problem, and to find improvements in your requirements. We will now transform this to a design, And there we have software, so we need to get things to work now. And in the book he has one way of doing this. I prefer the opposite way, but you can make your own judgment about that as the course progresses, how you would like to do things. More specifically, he likes to look at the dynamic part first and then do a static part. I like to do a static part first and then the dynamic part. But that is probably mostly a matter of preference. So, in this case, we start with the dynamics, so let's do it by the book. So we have a dude called the player. This represents the user interface in the application. So the player runs stuff in the software. In the final software, maybe pushes buttons or something like that. We will be doing a very simple user interface. Then we look at the requirements. What does the player do? Well, he rolls the dice. And this is also stated in the domain model. No, sorry. The first thing he does is actually he tells the game that he wants to play. He plays the game. That is the first thing. He opens the box and starts playing the game. So that is the first thing. So, looking at the analysis, well, we have a game here. We could have a link also from player to dice game that says plays, maybe. But that could also be understood by looking at that the player rolls the dice. So we have a dice game. And the player sends a message. Play. So what happens when you play the game? Well, the dice are rolled. Looking again at the domain model, have we got anyone that has intimate knowledge about the dice? Well, the dice game contains the dice. So, okay, well, let's have the dice game to manage this. Roll, and we decided on 2 dices, so we of course need to roll the second one too. Something like that. And what do we need to do then? Well, we need to know the value of the dice and check the sum. And we need to have knowledge about the dices to do this. And once again, the dice game has the knowledge of the dices. So let's call some function here, get value, maybe, get value. And then we can compute the sum, and we can return something, win, lose. And that is maybe all we need to do. Now the user interface can display a win message or a lose message. So this is how this requirement plays out, how it works in the design. It's a dynamic side of things. You see function calls and the order of function calls. And time progresses downwards here. First this happens, then roll happens, then roll again, then get value, then get value, and then we can return, and then we're done. So this is an interaction diagram, a sequence diagram to be more precise. To get a static view, we make a class diagram. And basically we have two types of classes here. We have the dice game and we have the dice. Dice game. I think that will suffice. And the dice game has one function, play. The dice has one attribute, I call it value. It's an integer. It has two functions, roll and get value. And they are connected because the dice game uses functions in the dice class. It has objects and it uses functions on these objects. Roll and get value are called from a dice game object. So these are objects. You have a colon first, and here you even have a name of the object. And here we have classes. So we need some kind of a link here. And we need to name it MD1. And we need another one, MD2. So that is the class diagram for this sequence diagram. So using a sequence diagram, we can more or less generate a class diagram. Because we can look at the objects, the type of the object, and we can look at the member functions or what you are used to calling them. And we can make certain decisions. And for example, okay, we know that we need to store the value in the dice. Because first we call roll and the value is set, and then we call get value to get the value. So we make certain decisions here also. We could make another decision that you get the value directly from roll, or that get value rolls the dice automatically. So, but we have made some design decisions to stick with this. Yes, that was a class diagram at the bottom and a sequence diagram. So we will look at the code. I will look at the time, and we have a good amount of time actually. So Visual Studio, new project, console application, C# Windows. Let's go somewhere else. I will just put it here. Dice game. Okay. Okay. Okay, it will be all right there. I will move this to Git later on. So, okay, we get some first function, some start of the program generated for us, and basically this is a little bit different depending on implementation language. In Java it looks similar, but it's not exactly similar. In C++ you have some other way of starting the game. So, dice game. And the thing that is needed is to call play. Oh, det kan vi göra. I will just try to find that. I'm trying to up the. Anyone knows where that is? maybe that is a little bit more viewable. So we start up by doing an instance of the dice game, and then we call play. And maybe we should just do this if statement if that one returns like true. Okay, that is our fantastic user interface. And we now need to create the dice game class. Also, I should say that I'm more used to C++, so sometimes I mix up the syntax. Let's just do something like that at first and try to compile and see what happens. Okay, you are a winner. That is not that hard. False. Sorry. So, okay, things seems to be working at least. So now we need to add the dice. D1. I have some auto-completion. And D2. D2, they were named. Need to create them. And D1, become new dice. To roll them. D1, roll, and D2, roll, and we should MD1 get value, MD2 get value. So, created a few objects called roll exactly as we stated in the sequence diagram. First we call roll on the D1, and then we call roll on the D2 dice object. And then we get the values, and we compare them to 7, and we return true if they are. So we now need to add the dice. Has a value. So, something like that, at least it should compile. No. Okay, and 0, 0 is of course returned, so we need to roll, make the implementation for the actual roll. And this is, well, a little bit more complicated than you might think. So this is basically an implementation detail. To get random things working properly in C#, you need to have a random object of type system random. And if you create the random object down here in role, two similar objects will be created really close to each other, so they will generate the same values for the two dices all the time. So we need to have some shared object that both the dice objects can use. So use a static variable, and it's private to this class, so we need this to get the random things to work in C# in a good way. So that's not really part of the more generic object-oriented design. Let's run this and see what happens. I should probably lose a lot, but maybe we can get at least one win here. This does not seem to be my day today. Is something not that good? This seems a little bit strange. Let's just put a breakpoint there, and let's debug it and see what we have. Get 6 and 6. That is not that likely, but okay. And 2 and 2. Three and 3. That was kind of strange. So there is some kind of problem here. Oh, sorry. So we had this problem that I actually mentioned because I forgot to write static. Thank you. So this was a good example of that the implementation details are not that easy. So maybe you should do a little bit more of design. Anyway. Looking at the implementation, if we go out here into the user interface, did not keep the. We can see the calls here. Play. This is recognized also from the sequence diagram. This is the first call. Inside this operation play, we will have first calls to roll, and then calls to get value on each of these two objects. Roll, roll, get value, and we return something. And if we were really good at this, maybe we should have added these details also to the design here, bool. And that should of course be like that, and return an int. And in our very large project and implementation, we could have divided this, so one coder got the dice game, and another got the dice, and they could implement this in parallel and make the implementation twice as fast. Maybe that's a little bit of overkill, of course, for this small of a program, but making these kinds of sketches or blueprints at a good level of detail that is supports your idea of what to use them for. You can use them for example, dividing tasks when working. Questions? Nothing. So this is basically what we will be doing in this course. We will be looking at how to do analysis tomorrow on Thursday, I think. And you will be working in the first workshop with the analysis. And the best part of the course, the biggest part of the course is focused on design. So we will be doing a lot of designing and looking at how different design solutions, what they actually mean when implementing them, looking at how an implementation can be transformed into a design, and also reasoning more about, okay, the properties of this design. What do we gain by having the implementation in this way? What do we lose? Can we make it somewhat better? Can we compare two different designs and say, okay, this one is better in this way, this other one is better in this way? Which one should we choose for our implementation? So we will try to start reasoning about software development and implementation at a higher level, not thinking about if statements and while loops and stuff like that, but rather how are things connected? What kind of properties do we get when things are connected in this way? Do we want these properties, or do we want some other properties? Should we change our design? And we will look a lot at standard solutions, because you are not the first ones doing this. And there has been a lot of software developed, and people have taken their designs and looked at them and seen that, okay, we have these 5, 10, hundreds of projects. They have had this problem. They have solved it in a somewhat similar way. So we have abstracted that into something called a pattern, a solution for something. And you can take this solution and you can implement it in your own way. And basically that is what the course is about. My personal goal is to get you to reason more about implementation, reason more about programming, taking this step upwards in abstraction, implementing maybe things, the same thing in different ways, and thinking about what happens if I solve this problem in this way, what happens if I solve this problem in another way. Because we can implement stuff in many different ways that does the same thing, but in different ways. So, okay, that is all for now, and see you not tomorrow, but on Thursday, I think. Yeah. Bye for now then.